Hello students, welcome to JScience Hub. Today we are going to study about measurements associated with electricity. Think about your day-to-day activities. Most of the time you are using the appliances or the instrument which work on electricity, right? Because electricity is very user-friendly and it can be easily transferred from one place to another. So in this video we are going to discuss about what is electricity, how we can measure the amount of electricity, what is voltage difference, and what is resistance. So let's enter into this video. First, think about a circuit which made up of batteries, switch, conductor and bulb. If there any break or if the wires are not joined properly, the bulb won't light up, right? So it shows the electricity can only flows through the closed circuit. Electric current consists of moving charge particles. So the charge particles are moving around the closed circuit. To make sense of electric circuit, you will have to model the behavior of current in circuit loops. Now we will consider how electric currents can be measured and how we can make sense of this measurement. The electric current in one part of a circuit is measured with an ammeter. Ammeter is an instrument to measure the amount of current. It gives the reading in ampere. To make the measurement, a gap is made in the circuit and the ammeter is connected into that gap. So you are connecting the ammeter in a series to the circuit so that the charge particles moving around the circuit must pass through the meter. From this you can measure the amount of current flows through the circuit. Since the ammeter is connected directly into the circuit, it must have a low resistance so that it does not reduce the flow of charge which it is being used to measure. So what does the ammeter actually measure when it is connected in a circuit? You might visualize the working of an ammeter as counting charges as they move through the instrument. To see how many pass each second, the amount of charge passing per second is a measure of electric current. Lots of charge particles passing per second, it means a large current, right? So we can define this as electric current equal the amount of charge passing per second. So from this we can simply define electric current is the rate of flow of charge. When an ammeter is used to measure the size of an electric current, the reading from the meter is in the unit of ampere. Connect the ammeter into the circuit in series so that there is no branching. The current in the wires will be the same as that in the ammeter. So the unit of electric current is the ampere, okay, and the symbol of the ampere is A. A center zero galvanometer or a center zero ammeter or millimeter can be used to identify the direction of the electric current. In a symbolic diagram, we use this symbol for the ammeter. When you observe the ammeter, you can find out two terminals. They are positive and negative terminals. Usually the positive terminal is red in color and negative terminal is black in color. When an ammeter is used in a circuit, the terminal should be connected correctly. Ammeter is suitable to measure large current, while milliammeter is suitable to measure small current. So what is potential difference? Usually electric current flows from a high electric potential to a low electric potential. So the difference of electric potential energy between two terminals of the cell is called voltage or potential difference. The positive terminal of batteries have high potential than the negative terminal. The voltage between positive terminal and the negative terminal of electric cells and batteries are marked on them. For example, the simple dry cell we are using is having 1.5 voltage. The car battery is having nearly 12 voltage. So the symbol of the potential difference is V and the international unit is volt. We use the voltmeter to measure the potential difference. Like ammeter, the voltmeter also having positive and negative terminals. Usually positive terminal is red in color and negative terminal is black in color. Voltmeter is connected parallelly to the circuit to measure the potential difference between 2 points. Accurate measurements of current and voltage have to be taken in many instances in our day-to-day life. For example, to make sure the voltage supply to the house and factories are of accurate voltage. By measuring the current the electrical appliances consume, we can detect the defects. So when repairing, to identify whether the parts of the electrical appliances are functioning properly, we should measure accurate current and voltage. To measure measurements associated with electricity in powerhouses and electrical generators, we should measure the accurate amount of current and voltage. Okay, so these are some examples of instances where we should find out the accurate amount of current as well as voltage. To study about the resistance of a conductor, we can set up this simple experiment. In the gap between A and B terminals, we can use copper and iron wires. You know copper and iron are conductors, right? Because they are metals. When you use the copper wire, the bulb is more bright and the ammeter reading also high. But when you use the iron wire, the brightness of the light is reduced as well as the reading of the ammeter is reduced. Okay, so this shows at these two instances the current flowing through a circuit is changed. So from this we can conclude, according to the type of conductor we are using, the current flows through the circuit also will change. So electric current flowing through a conductor depends on the material that is made of. Okay, we can define the resistance as an obstacle caused by a conductor to the flowing current through it. We use capital R as a symbol to denote the resistance, and to measure the resistance we use ohm. When the resistance of the conductor is increased, the current flowing through it decreases. Resistance is inversely proportional to the amount of current passing through that conductor. Electrical parts that possess the property called resistance are known as resistors. These resistors are used in the circuit to control the amount of current flows. There are different types of resistors we use in our day-to-day life. Some are fixed resistors, they have a fixed resistance value, while some are variable resistors which have a certain range. In between, the resistance can be changed according to our wish. So hope you all enjoyed the video and understand the measurements associated with electricity. Like the video, share and subscribe to J Science Hub for more videos related to science.